So chapter 4, question 16, asks you to write the group number, that's the first thing, and then to draw the electron dot symbol for several different elements. Now, first, the group number is the column that the element's in. And then second, the electron dot symbol. The electron dot symbol shows you the essential parts of an atom in order to figure out how it will connect with other things. Now remember that an atom has that nucleus in the center, sort of like the sun at the center of the solar system, and then the electrons flying around in layers. But the key layer is the outermost layer. That's the layer that bumps into stuff in the outside world and determines whether an atom sticks to or reacts with that stuff, or just bounces off like a billiard ball. So that layer has the special name, the valence layer, and any electrons in that layer, any electrons are called valence electrons. So those are like the bumps or the ridges on a Lego. They allow the Lego to stick to other Legos. And so they're really, really important. Now this inner part, the part that has the inner electrons and also the nucleus, that is summarized by the symbol. So this whole thing here is going to be summarized by the chemical symbol, and then just the outer part, the valence electrons, are going to be drawn as dots around it. So I think this will be clear when we see an example. So let's start with sulfur. Now, the first thing we want to do is to find the group number it's in. Sulfur is over here, so it's in group 6A. So that's the group number, that's the first thing they're asking for. The second thing is to draw the electron dot symbol. And what you do is you write the symbol, so S for sulfur, and that stands for all the nucleus and all of the electrons on the inside of the atom. The only thing that's left to draw are the valence electrons, the electrons in that outermost shell, the ones that determine how the atom sticks to the stuff around it. Now, when we place these electrons here, we want to think of this sulfur as sort of being in a box that has 4 sides. And here, I'll just put that to the left. To the right, I'll draw the actual Lewis dot symbol. So we're keeping in mind those 4 sides, and what we're going to do is put an electron on each side before we start pairing them up. So because sulfur is in group 6A, it has 6 valence electrons. You can start on any side. I'm going to start on the right side. Now there's 1 on that side. Now I'm going to go to the bottom. There's 1 on that side. Left, 1 on that side. Top, 1 on that side. I've used 4 electrons. I have 6 valence electrons that I have to include. So now that I have 1 on each side, I can start pairing them. So a second one on the right side and a second one on the bottom. And this is the electron dot symbol for sulfur. The S represents the nucleus and all of the inner electrons, and those outer electrons, the valence electrons, are drawn in as dots on sort of the side of of a box, on each of the 4 sides of a box around the sulfur. And the way it's going to work is those unpaired electrons, so the electrons that aren't next to another one, those unpaired electrons are going to be places where this atom can connect with other atoms. So the electron dot symbol can be really useful that way in the sense that it'll show you how atoms connect. Let's try to do the same thing for nitrogen. So first, the group number. In nitrogen, in addition to it's very cold, it's a clear liquid, it's also 79% of our atmosphere. And that's what the photograph in the top right is trying to communicate. So 79% of the air you're breathing right now is nitrogen. You can feel how nitrogen feels just by waving your hand through the air. So, nitrogen. Nitrogen is in the top right. It is in group 5A. So for the group number, that was one of the things they're asking, we'd write 5A. Now for the electron dot symbol, we'll write the symbol, so the N, and because this is in group 5A, it has 5 valence electrons. Now I'm going to put 1 on each side before I start pairing them. So there's 1, 2, 3, 4. Now that I have 1 on each side, I can start pairing them. There's the 5th one, and that is the electron dot symbol. So you could see that nitrogen can connect with 3 other atoms because it has 3 electrons that are not paired up And you're able to see that because of the electron dot symbol. Okay, let's try the same thing for calcium. So first, calcium is right here. It's in group 2A, so the group number we'll put in for that is 2A. To draw the electron dot symbol, the first thing you want to do is to draw the symbol, and the symbol represents the nucleus and all of the inner electrons. We just have to write in the outer electrons, the valence electrons. Because the group number is 2A, there are going to be 2 valence electrons. So I'm going to put one on each side, thinking of this as being in a box, and only if I have one on all 4 sides would I start pairing them. Since I only have 2, I put 2 dots, and that is the electron dot symbol for calcium. It has 2 places where it can connect to other atoms. Let's try the same thing for sodium. So sodium is in the sort of top left. It's in group 1A, so the group number will be 1A. The electron dot symbol, you write the symbol, so Na, and that represents the nucleus and all of the inner electrons. We just have to write the outermost electrons, the valence electrons. Because sodium is in group 1A, it only has 1 valence electron, so we only have to put 1 dot on a side of the sodium. So there's only one place where the sodium would be able to connect with another atom. The next one is gallium. Now gallium is a metal. Now mercury is the only metal that's a liquid at room temperature, but gallium does melt at body temperature. So if you put it in a warm glass of water, or if you put it on your hand, it'll start to melt, and that's what you see it doing here. Gallium is sort of in the middle, maybe a little toward the right of the periodic table. It's in group 3A, so the group number we'll write is 3A. Then the electron dot symbol, we'll write Ga for gallium, and that's representing the nucleus and all of the inner electrons. And then we just have to write in the valence electrons. Because gallium is in group 3A, it has 3 valence electrons. I'm going to put one on each side, thinking of this as being in a box. So there's one on the right, one on the bottom, one on the left, and that's it. Those are my 3 valence electrons. So that would be the electron dot symbol for gallium, showing how gallium has 3 places where it can connect with other atoms. Okay. Chapter 4, question 17 is really the same thing, but with a few more elements. So let's dive right in. Let's go through that process for carbon, which can be diamond, if it's squeezed in the right way. So carbon is in the top, sort of middle right of the periodic table. It's in group 4A, so the group number will be 4A. That was the first thing that they wanted us to write down. The second thing that they want us to write down is the electron dot symbol. So first you write the symbol, capital C for carbon, and that's representing the nucleus and all of the inner electrons. Then we just have to write in the valence electrons, the outermost electrons. Because carbon is in group 4A, it's going to have 4 valence electrons. And I'm going to imagine this carbon as being in a box, and I'm going to put one valence electron on each side before I start pairing them. So I'm going to start on the right, then I go to the bottom, then I go to the left, then I go to the top, and there I've already written in the 4 valence electrons that carbon has. So that's the electron dot symbol for carbon. It has 4 places where it can connect with other atoms. How about oxygen? And here you see liquid oxygen on the right. So oxygen is sort of in the top right of the periodic table. It's in group 6A, so its group number is going to be 6A. To draw the electron dot symbol, draw the symbol, that oxygen. That represents the nucleus and all of the inner electrons in the atom. We just have to write in the valence electrons, the outermost ones now. And so we have, because it's in group 6A, we're going to have 6 valence electrons. So we want to draw 6 dots. And I'm going to put one on each side of the oxygen before I start pairing them up. So one on the right, one on the bottom, one on the left, one on the top. So now I've added 4, but I still have 2 more because I have 6 valence electrons. So now that I have one on each side, I can start pairing them. So a second one on the right, a second one on the bottom, and there you have the 6 valence electrons. You can see that oxygen only has 2 places where it can connect with another atom. And so hopefully now it would make sense that it can connect with only 2 hydrogens to form water. H2O. All right, let's try this for argon. So argon is a noble gas, but when you send electricity through it, it lights up in this bright blue. So argon is in the right side of the periodic table over here. It's in group 8A, so the group number we'll write is 8A. So to draw the electron dot symbol, we'll write the symbol AR. That's representing the nucleus and all of the inner electrons. The group number 8, the group A number, is the number of valence electrons it has, so it has 8. So I'm going to put 1 on each side before I start pairing them up. So 1 on the right, the second one at the bottom, the third one at the left, the fourth one at the top. So now I have 1 on each side. Now I can start pairing them. The fifth one on the right, the sixth one on the bottom, the seventh one on the left, the eighth one at the top. So that's the electron dot symbol for argon. Notice how all of the electrons are paired. It's because all of the electrons are paired that argon isn't going to connect to any other atoms, and that's what makes it a noble gas. The noble gases don't really react with other things because all of their electrons are paired. All of their valence electrons are already paired. So they're not very sticky. All right, let's try lithium. So lithium is in the top left. It's in group 1A, so the group number will be 1A. That's the first thing you'd want to write down. The second thing you'd want to write down is the electron dot symbol. Write the symbol. That's going to represent the nucleus and all of the inner electrons, so Li. And then because lithium is in group 1A, it has 1 valence electron, so I only have to put 1 dot next to it, and that's the electron dot symbol for lithium. It has 1 place where it can connect to other atoms. All right, let's try chlorine, and here you see a lot of very toxic light green, sort of yellow gas. That's chlorine gas leaking from this plant in this photograph. So chlorine is in the top right of the periodic table. It's in group 7A. So the group number will be 7A, and that was the first thing that they were asking for in this question. The second thing was the electron dot symbol, and for that, write the symbol Cl, capital C, lowercase l, and that represents the nucleus and all of the inner electrons. We just have to add the valence, or outermost electrons. Because chlorine is in group 7A, it has 7 valence electrons. So I'm going to put 1 on each side of each of the 4 sides of chlorine before I start pairing them up. So 1 on the left, second on the bottom, 1 on the right, second on the bottom, third on the left, fourth on the top. Now that there's 1 on each side, I can start pairing them up. So 5th on the right, 6th at the bottom, 7th on the left, and there I've added my 7 valence electrons. That would be the electron dot symbol for chlorine, and you can see that chlorine only has 1 place where it can connect with other atoms at that 1 unpaired electron. So you can see how you can draw these electron dot symbols just based on the column that an element is in. And it gives you a lot of information because it lets you see how an element can connect to other atoms and how you can use these atoms to create larger compounds that can act as, say, drugs or medicines.